Hello all, let's learn about edit distance. Levenshtein distance, also known as edit distance, is a way to measure the similarity of two strings. It is used to calculate the distance between two strings or to convert one string to another string. This is done by using minimum number of operations: insertion, deletion, and substitution. There are two approaches to find the minimum distance. They are bottom-up approach and top-down approach. In this video, we will learn to find minimum distance using bottom-up approach. Three operations used for doing this are insert and delete with cost 1 and substitution with cost 2. Let's see some examples to understand better. In this example, to convert the string from the word LEDA to the word deal, we see that the letter L is substituted with letter D with letter A with letter L. Since three operations are done to achieve the target, the minimum edit distance will be 3. Similarly, to convert a string from the source word drive to the target word drivers, we see that the letter R and the letter S are inserted. Since two operations are taking place here, the minimum edit distance will be 2. Let's see an example in detail using Levenshtein distance to convert the string from the source word eat to the target word earth. Initially, there are 0 iterations. Then, since we are inserting e, we add +1 with left arrow. Similarly, inserting A, R, T and H by adding +1 with the previous element. Now we are deleting E and so adding +1 with down arrow. Similarly, we do the same for deleting A and the letter T. Here we see that the source letter E matches with the target letter E. In this case, we write the diagonal element and give arrow mark in the direction of the lowest number. Here, in the diagonal, there is 0. So first we write that. Then, since 0 is the least, we assign arrow mark towards 0. Here, we are substituting A. So, for this, we add +1 for insertion and deletion and add +2 in the diagonal element. That is, we get 1, 3 and 3. The least here is 1. So, we write that and give arrow mark towards the least, that is 0. Similarly, we can complete the entire matrix. Finally, we trace back the path from upper right corner to reach the initial state from where we started. Real-time applications of edit distance. Spell checker. Spell checkers use Levenshtein distance to suggest corrections of misspelled words in real time as you type. The algorithm can quickly identify potential corrections based on the minimum edit distance. Another important application is autocomplete and search suggestions. Search engines and text editors often employ Levenshtein distance to provide autocomplete suggestions and search query corrections. This helps users find relevant information more efficiently. Another important application is the recommendation system. E-commerce and content recommendation systems can use Levenshtein distance to find similar products or content in real time based on users' input or preferences. Another important application is the recommendation systems. E-commerce and content recommendation systems can use Levenshtein distance to find similar products or content in real time based on the user's input or preferences. Real time applications of Levenshtein Edit Distance are many. Some of the important ones are in speech recognition, text to speech synthesis, code completion, and in customer support chatbots. That's all for the day. Thank you.